example 4, write the following equations without logarithms. So in part A we have a logarithm of A equals 2 times logarithm of C plus 3. Now naturally we suppose here that A is positive and C is positive in order for us to be able to evaluate these logarithms at all. So A and C have to be positive. Now if we want to get rid of logarithms, we have to use the strategy of replacing both sides of this equation by a single logarithm and then comparing those logarithms come up with the answer. So the left hand side is just a single logarithm, so I'll leave it without any change, but on the right hand side I can use the power rule law to replace the first term by the natural logarithm of c squared, like this, plus, and now I can use another law which says that 3 can be replaced by the logarithm of e to the power of 3, okay, because we know that the natural logarithm of e to any power y is just y, okay, because this was one of the laws outlined in the first video about the laws of natural logarithms. So let me now use another law. We have the sum of two logarithms, and we can now use the product rule law and replace the right hand side by a single logarithm. So therefore the left hand side is logarithm a equals the natural logarithm of and we have c squared times e cubed, like this. Now on the left and on the right hand side we have a single logarithm, and since a logarithmic function, the natural logarithmic function, is 1 to 1, we can safely say that a must be equal to c squared times e cubed, and this is the first part solved. So we got rid of logarithms and we wrote this equation in an equivalent form without using logarithms. Just let me repeat one thing here. This is equivalent to this only when a and c are positive. Now let's go for part B. In part B we have the natural logarithm of quantity m equals 3 times the natural logarithm of a minus 2. So in a very similar way, we will suppose that both m and a are positive in order for those logarithms to be defined. So if you want to be able to find the value of the logarithm, you have to take it from a positive number. So m and a are positive. Now I will use the same strategy. So the left hand side will be without change here, and on the right hand side I can use the power rule law to say that this would be natural logarithm of a to the power of 3 minus, and the same law used as before, number 2 can be written as the natural logarithm of e to the power of 2. Okay, so natural logarithm of e to the power of y is y, and therefore natural logarithm of e to the power of 2 is just 2. Now we can use the quotient rule law to replace the right hand side by a single logarithm. So it's the logarithm of m equals the logarithm of the quotient a cubed over e squared, like that. Now again, since the natural logarithm is the function that is 1 to 1, we can say that m must be equal to a cubed over e squared, like that.